All right, so in 3.6 we have some more models here. We're just going to work through the problem and see where this quadratic stuff comes up and see if we can kind of figure some stuff out. Okay? So first, let's draw this picture. Do you guys remember how to graph that quickly? What shape is this? Shifted? Down 5, right? So hopefully you can just pencil in those points. Okay, so that's the first part. Just draw the parabola. And now it says draw a point on this graph somewhere. Okay. So I'm going to put a point right over here. It doesn't matter where it is. And I'm going to label it P, which is x comma y. Okay. Now, let's jump to here. We're trying to look at the distance from any point on this parabola to the origin. So if I compare this point to the origin, I want to figure out what this distance is. Okay? And so currently, we have 2 points, 0, 0. And since I don't know the coordinates for that point, we just leave it as an x and a y. Okay? So now, could you guys set up, using the distance formula, which is something you've already learned, right? Using these 2 points together, what the distance equation is going to be? What would it look like if I plug everything in? What's x2 minus x1 in context with these points? X minus 0. Good. Plus, and then the y2, that should be a plus, by the way, not a minus. I didn't even see that. What's y2 minus y1 here? Okay. And we can simplify that. X minus 0 is just x, so we have x squared. And then y minus 0 is just y, so y squared. And so our distance model is that the distance from any point on the parabola to 0, 0 is just going to be the square root of x squared plus y squared. Okay? Now, we know that we cannot work with 2 variables, right? We're used to having quadratics, but with just x's, x squared, 2x, that kind of thing. So what we're always going to do, every time we set up our model, if we see 2 variables, we're going to use what the definition is for y in the problem and substitute it in. So the next step we're going to have is that d is going to be the square root of x squared plus, and then now, instead of y, I'm going to replace it with x squared minus 5. And then that needs to be squared, obviously. Okay. Does everybody follow that so far? Okay, and this is your answer right here. Okay, we're going to use our calculators quite a bit for this. Actually, let me go run and get mine. But you don't have to multiply it all out and FOIL and combine, just leave it like that. Okay, less is more right now. Okay, go ahead and take your calculators out. Okay, we'll use them in just a minute. But, you should be able to at least answer these two questions, right? Now, let's answer this first one without using the formula, just by looking at a picture, okay? Just so that we understand. A lot of times you guys do things and you get answers and they should make sense, but you don't really think about it. So one thing that I think we can get better at is, does the answers we're obtaining actually make some sense, okay? So let's look at if x is 0. If x is 0, okay, what's y going to be? So we're talking about this point, 0, -5, right? How far is this point to the origin? So what's this distance here? 5 units, right? Pretty easy. Now, in theory, if we've done things correctly, I should be able to plug in 0 into this formula, right? And it should also give me that my distance is 5 units. So if I plug in 0, we get 0 squared, which is 0, plus 0 minus 5 squared, which is going to be 25. And the square root of 25 is indeed 5, right? Now, why would you use this complicated formula when we're right here? Well, if we're somewhere over here, you can't just look at it and say, this is my distance, right? This is easy because it's right below it. If it's off a little bit to the side, then we don't necessarily know what that distance is by just looking at the picture. If x is 1, let's go ahead and find that. What are we going to get? Yes?
17.
Very close. Root 17, yeah. We didn't. Don't forget about the square root. So if x is 1, we're talking about this point right here. From this point to 0, 0 is going to be root 17 units away. So just a little bit more than 4 units. Everybody understand that so far? Okay. Now, this is just little details getting you to understand how this formula works. What the most important piece for you is going to be is, can we find the smallest distance possible and when that's going to occur? So if we go to y equals, okay, let's type in this formula here, this goofy formula, into the equation for y1. Okay, let's graph it. Okay, so here's the graph, right? Let's look at a table real quick. The x values represent the x coordinate of the point, right? But for this specific function, what did y really represent? What does this goofy formula tell us?
Closest distance from the origin to any point.
Remove the first few words and the last few words that you said. It begins with a D. Represents the distance, right? So the y coordinate, okay, is going to represent the distance from 0, 0 to somewhere on the parabola. Does that make sense? So right here where it says, look at your graph, what does every point represent? X is going to be X, but the output, the Y values, that's the distance that we're talking about in the problem, right? So over here when X was 0, our distance was 5 units. When we went to 1, it was a little more than 4, right? What we're trying to do now is find for what values of X is D the smallest. How can I do that on the calculator? How do I find the smallest values?
Minimum.
Second trace, and we'll combine that with what Philip said, minimum, right? It looks like there's two potential ones, right? Let's go ahead and find the first one. You guys remember how to do this? Second trace, minimum. Left bound, right bound. So potentially, when X is about negative 2.12, what's our distance there?
When the graph looks like that, do you want us to like find the minimum for both sides, or should we just?
We should find the minimum because they're asking us for the lowest point period, right? It is possible that this point might be a little lower than the other point, so we do want to find both just to make sure. Now, it looks like they're going to be the same, right? But we're not 100% sure. But for this first point, we have negative 2.12 approximately. Remember, this y represents a distance, and so I'm getting a distance of about 2.18. Do you guys understand how we're getting those? Okay. Now, if we find the minimum on this side, we should expect them, I mean, they look like they're at the same height. We get exactly the same values. The only difference is positive 2.12, right? But we still get a distance of about 2.18. Okay? So to answer the question, for what values of x is distance the smallest, we're going to say plus or minus about 2.12. Okay? And so what that means then, on your graph, if you were to go to the point 2.1 or whatever, that distance is going to be the smallest on the parabola. Okay? 5 is too far away, and if we get way up there, we get further and further away from 0, 0. Does that make sense? Okay? Any questions on that? Okay. Let's go on to example 2. So here we have a right triangle that has a vertex on the graph of y equals 9 minus x squared. So remember that this is a parabola upside down, shifted up 9. So something like this doesn't have to be a perfect picture. And so they tell you where the points are. We have one point on the parabola somewhere in the first quadrant. So here's our point, x comma y. Another point is at the origin. And then the third point is on the positive x-axis at x comma 0. So right below, right here, we have a third point, x comma 0. And they're looking for the area of this triangle. Okay? So that's the setup. And now we tie this to some information that you should already know. What is the formula for an area of a triangle? Okay? I'm going to go half length times width. I see ahead that they're using base and height, so I'm going to actually use B and H, but it's the same thing. Okay? So half times base times height. Now, looking at this triangle that we have here, how long is the base? We don't know it, but what would it be if I knew this? Whatever x is, right? Does that make sense? So the base is going to be x. What's the height here? Very good. And so now, if I substitute these values into our formula, we get area is going to be 1/2 times x times y. So I'm changing the formula from 1/2 base height or 1/2 length times width and using the symbols that were given to us in the problem. Everybody understand that so far? Okay. And now, just like before, we're always going to clean our formula up. We don't want two variables, so we're looking for a way that I can get this y out of there, right? Well, they tell me what y is at the very beginning of the problem. They say y is 9 minus x squared. So I'm going to rewrite the formula and replace y with 9 minus x squared. And there's our area formula. Okay. Are there any questions on these two problems? Okay, so part of this little section is taking a picture, writing out what the equations are going to turn into with the quadratics that we have. Another is like problem 1, where you actually have to find certain values that meet certain conditions. But it's all in the calculator, you guys. Okay? You don't have to do any weird stuff. It's just, do you remember how to find minimums or do you remember how to find maximums? That's all we're doing. It's just now we're tying it into this section. Does that make sense? Okay. Let's skip the rest of the examples in 3.6 and let's go on to 4.4. Okay. We'll get through as many of these as we can. Your homework tonight, you guys, is going to be all of 3.6 and all of 4.4. But I'm telling you, there's only like a couple of questions in each section. Does that make sense? It's like maybe 3 questions tops. So 6 total. I think you guys can handle that. Okay? So example 1, we have the price of something, quantity, okay, and they relate that the price is going to be negative 1/3 times x plus 100, okay? X again represents the quantity sold, and P represents the price, okay? And now, the one thing that's you have to kind of connect the dots with is revenue, okay? So revenue, by definition, is number sold times price. So if you're running a business or a company, and that's kind of fading, you want to figure out what the revenue is for a product. You take the number of products that you sold or the number of items, and then you multiply that with the price at which you are selling them, right? So it's a pretty straightforward concept. If you have 200 cookies and you're selling them at $1 a piece, what's the revenue for that? $200, right? You should have $200 in your pocket. Okay, that's what revenue is. Okay, we're not talking profit or anything, right? Because obviously, if we factor profit in there, you might have to take into consideration how much money you spent to buy the ingredients to make the cookies, right? So this is not a profit issue. It's just literally how much money was made from your sales. Everybody understand? Okay, so number sold times price. So to find a revenue formula, the number sold is X. It's always going to be X, okay? X represents the number of items sold. And the price, they always are going to give to us, okay? Here's our price equation. So we're going to substitute that in. And now we got negative 1/3 X plus 100 substituted into that. Okay, and this is a normal quadratic equation. So I would recommend, it's not a goofy one like the previous page. Let's just multiply this out and make it look like the normal quadratics that we've been studying. Okay, so there's our revenue model. Take a few seconds, figure out the next question. So what's the revenue if we sell 100 of these items? All right, what are we getting?
Lots of big.
What is it?
Got like a really big.
Really big. Well, what is it?
Wait, that's wrong.
How do you know?
It's a negative.
I'm actually glad you said that. Okay. So Jared got a negative answer. Does that make any sense? No, because you're selling 100 items at whatever price, right? So it should not be a negative answer. So at the very least, if that ever happens to you, you should have enough recognition right then and there to say, you know what, let me redo this because that shouldn't happen, right? Anybody have a not negative answer? Yes, Michael.
6,700.
Is that an approximation?
6,600.
And how many cents? Okay, that sounds better. It's a good approximation. He did that without a calculator, so we'll allow it. Okay. Do you guys see where we're getting this? Okay, we're literally just plugging it into X. Okay, that's all we're doing is to get that. That's our revenue. Okay. Now, this question should be a review. What key word do you see in here? Maximizes, right? What do we use to find X anytime we're looking for a max or a min? Negative b over 2a. Very good. So, looking at our quadratic model, the opposite of b is negative 100. 2 times a, that's negative 1/3. Okay, so if we type that into the calculator carefully, okay, everybody getting the same thing? So 150 items. I don't know what we're selling here, but this is how many I should sell to get my maximum revenue. Okay? Second question, how do you find the maximum revenue now? What do you do with the 150? You plug it into the revenue equation. So R of 150, substitute that in. 150, not 50. Man, I'm pressing the wrong buttons everywhere. Is that what everybody got? Okay, just making sure. $7,500 is the best case scenario here. Okay? Any questions on that? Okay, let's see if we can quickly do the last problem, which is, oh, forgot to answer the question. What is the price that we need to sell? How'd you get that?
7,500 divided by 150.
Now, if you guys don't see that, I always like to treat things very literally. So you know how here it was, they asked me for revenue, so I plugged it into a revenue equation, right? If they want a price, there's a price equation right at the beginning that you could use if it's not similar to that. So you could just substitute price at 150 is negative 1/3 times 150 plus 100, and that also gives you the $50. Okay? Does everybody understand that? Okay. Let's look ahead to, let's at least set up this third example here.
I don't think we have.
Yeah, we do. Farmer, 2,000 meters of fencing. But there's already a fence on one of the sides. What is the largest area? So we want max area. Cool. let's call this x. Let's call this dimension y. What would the area for this rectangle be according to my labels? X times y. Okay? Now, where does this 2,000 meters come in? Well, this 2,000 meters
Perimeter.
goes to the three sides of the rectangle I need fencing for, right? So 2,000 should equal what?
X 2x plus y.
X plus y plus x. Does that make sense? 2x plus y then? We don't need the fourth side, so that's why it's not quite a perimeter equation, but it's still perimeter, really. Does that make sense? Okay. The only part that's difficult about this problem, you guys, if you could just hold on for 30 seconds. Before, they literally told you, here's what y equals, right? Your job is to figure out y by just subtracting the 2x. And then this now gets substituted into the formula. So it'll be x times 2,000 minus 2x. Do you guys see where I'm getting that from? And now it's the same problem that we just did. Distribute, get a quadratic, use the shortcut, plug it in, you get your maximum. Does that make sense? Okay, I know we didn't have time to quite finish everything there, but we can finish that up tomorrow if need be. Please make sure that you do the math lab, because we're done with I'm done teaching you new stuff. So your exam is coming up fast, okay?